Okay, students. So today we are going to have some discussion with the multiple choice questions. Multiple choice questions for the chapter alcohols, phenols and ether. Okay. So the first question which we are going to discuss here is asking which one of the following is most acidic, and the options are A CH3OH, B CH3CH2OH, C CH3 twice CHOH, and D CH3 thrice COH. Okay, so we have to give the answer here about the following condition, that which of the given one is highly acidic, okay, is more acidic. So here the answer is A. Okay, the correct answer will be A. The reason is that acidic character of alcohols are decreasing. Okay, it is decreasing with the order that methyl group will be having the highest acidic nature, while the 1 degree alcohols, okay, from the 1 degree alcohols, the methyl alcohols or the alkyl alcohols, they will be having the highest acidity. Then comes the number for the 1 degree alcohols, then for the secondary or 2 degree alcohols, and then for the tertiary or 3 degree alcohols. Okay, so this is the reason why the answer will be A, because A is here methyl alcohol. And alkyl alcohols are the most acidic as comparison to that of the 1 degree, 2 degree or 3 degree. So this is the 1 degree alcohol, this is secondary alcohol, and this is the tertiary alcohol, primary, secondary and tertiary alcohol. So among them the methyl alcohol will be highly acidic. Question number two, which one of the following compounds would not be easily oxidized by potassium dichromate, that is K2Cr2O7, and sulfuric acid, that is H2SO4? Options are ethyl alcohol, that is CH3CH2OH, CH3 twice CHOH, that is a secondary alcohol, CH3 thrice COH, a tertiary alcohol, and an alkyl alcohol, okay, that is methyl alcohol. So here it is asking that which one of the given options will not be easily oxidized with K2Cr2 and H2SO4. So here the answer will be option C. The reason here is that if I am going to form the structure for the tertiary alcohol, so here it will be CH3 and CH3, and the carbon which is bearing the OH group, it is not containing any of the hydrogen here. So hence it is not possible here to oxidize this particular compound. Okay, in order to oxidize this particular compound, we will require some catalyst or other method will be there. But by simple K2Cr2 or H2SO4, it will not be easy to oxidize this particular compound. Okay. Next, question number 3. So what this question number 3 is asking, which of the following is expected to have highest boiling point temperature? Options: CH3, CHCl, CH3. 2-chloropropane, CH3, CH2, CH2, OH. That is butanol. Option C, CH3, CHOH, CH2, CH2OH. That is 1 comma 3. Sorry. That is but 1 comma 3 diol. Okay, and CH3, CH2, CH2, CH2Br, that is bromobutane. So here, out of this 4 options, we have to find out which one is having the highest boiling point. So the answer here is C. That is the di-alcohol. Okay, the group which is containing a compound which is containing di-alcohol. So alcohols are having higher boiling point than generally alcohols, they are having higher boiling point as comparison to that of the haloalkanes. Okay, they are having higher boiling point as comparison to that of the haloalkanes. And dialcohols, dialcohols, they are having higher boiling point among the alcohols which is having only single alcoholic group. Okay, single hydroxyl group. So here, if I am going to mention this particular alcohol as monoalcohol, so we can compare that dialcohols are having more boiling point or higher boiling point as comparison to that of the monoalcohols, and alcohols are having higher boiling point temperature as comparison to the haloalkanes. So here the dialcohol is the C option, and hence the answer will be option C. Next, phenol is more acidic. Phenol is more acidic than ethyl alcohol. Phenol is more acidic than ethyl alcohol because, what is the reason? So the 4 options here are: option A, phenoxide ion is more resonance stabilized than phenol. Option B, there is more hydrogen, bonding in phenol than alcohols. Ethoxide ion is less resonance stabilized than ethyl alcohol. And the last is phenols have higher boiling point. Phenols have higher boiling point than ethyl alcohol. So out of this 4 options, we have to give the correct answer. That what is the reason why the phenols are more acidic than that of the ethyl alcohol. So the answer here is option A. Okay, the answer here is option A. The phenoxide ions is more resonance stabilized than that of the phenols. Okay, so the greater acidic character of phenol is due to the more resonance stability of phenoxide ions as comparison to that of the phenols. Phenoxide Phenoxides are generally the compounds where we can see oxygen is been combined with any other metal. Okay, any other metal such as sodium phenoxide. So if I am comparing sodium phenoxide with phenol, so we will see that sodium phenoxide is more stable as comparison to that of the phenol. Okay, here the chances of removal of hydrogen is more as comparison to that of the chances of removal of that is sodium from this particular compound, and it is due to the presence of resonance stability in the phenoxide. This is phenoxide and this is your phenol group, and due to this reason we will see that the phenols are more acidic as comparison to that of the phenoxide or any other alcohols. Okay, next, which of the following which of the following is more reactive with HCl in presence of ZnCl2. Okay, so option A, CH3, C, CH3, CH3, OH, that is a tertiary alcohol, CH3, CH, CH3, CH2OH, a secondary alcohol, C, CH3, CH, CH3, OH, and the last is the CH3OH. So out of this four, which one is more reactive with HCl in the presence of ZnCl2? So here the tertiary alcohols are having higher reactivity as comparison to that of the secondary and the primary and the alkyl group of the alcohols. Okay, so here the tertiary alcohols are more reactive than the secondary, than the 1 degree, and then that of the alkyl alcohols with the HCl. Okay, with HCl in the presence of ZnCl2. Okay, so hence here the answer will be option A. Next, isopropyl alcohol is oxidized with potassium dichromate and H2SO4 to give. Okay, so option A, CH3CHO, that is an aldehyde, CH3COCH3, that is an ketone, CH3CH2 CH2 COOH, that is an carboxylic acid, and CH3 CH double bond CH2, that is an alkene. So isopropyl alcohol means CH3 CHOH CH3. This is isopropyl alcohol. So isopropyl alcohol when been oxidized with K2CrTO7 or H2SO4, then it will produce ketone. Okay, it will produce ketone here. So the answer will be option B. Correct option here it will be option B. Next, the IUPAC name, the IUPAC name of tertiary butyl alcohol is, okay, you have to identify the IUPAC name for the tertiary butyl alcohol. So first option 2-methyl propanol, 2-methyl propane 2-ol, sorry, 2-methyl propane 2-ol, 2-methyl butane 1-ol, propane 2-ol, and D is butane 2-ol. Okay, so these are the four options, that is A, B, C, and D. 2-methyl propane 2-ol, 2-methyl butane 2-ol, butane 1-ol, and propane 2-ol and butane 2-ol. So the formula for the tertiary butyl alcohol, tertiary means 3 carbon atoms will be attached with the carbon atom which is containing the alcohol group, CH3, CH3, and CH3. This will be the compound. So the name of this compound will be, if this is the main chain, then the name of this compound will be 2-methyl propane 2-ol. So option A will be the correct answer. Okay, option A will be the correct answer here. Next, Remer-Tiemann reaction. Remer-Tiemann reaction is useful for preparation of option A, benzaldehyde, option B, salicylaldehyde, option C, toluene, option D, acetophenone. Okay, so Remer-Tiemann reaction. So first we have to understand what is Remer-Tiemann reaction. So the Remer-Tiemann reaction is when phenol reacts with chloroform CHCl3, when phenol reacts with chloroform in the presence of NaOH at 340 Kelvin, NaCl and water is been removed out here. So the formation of sodium phenoxide takes place with a CHCl2 at the ortho position. Now, further of this reaction of this, okay, of this reaction of this compound with NaOH, more NaCl will be removed out from here, and the formation of an unstable compound which is CHOH twice will be formed out here. Then here, as this compound is unstable, so water dehydration will occur out here, and after dehydration, formation of an aldehyde group at the ortho position with the sodium and oxygen at the directive position will be present out here. And after the acidification, here the removal of NaCl will take place, and here we will obtain the salicylaldehyde. Okay, salicylaldehyde, or also called as 2-hydroxy benzaldehyde, 2-hydroxy benzaldehyde, which is also termed as salicylaldehyde. Okay, so the correct answer will be option B, the salicylaldehyde. Okay, ninth one. Phenol on distillation. Phenol on distillation with zinc dust, with zinc dust gives A. Benzene, B. Benzaldehyde, C. Benzoic acid, or D. Benzophenone. So here the reaction or the distillation of phenol in the presence of zinc dust will produce benzene. Okay, it will produce benzene here. So hence the answer will be option A, that is benzene. 10th, the end product of the given reaction is NaOH, then CO2 at 140 degrees Celsius produce B, then reduction in the presence of water produce C, then in the presence of anhydride it will give D. So we have to find out D. What is D here? Is it salicylic acid? Is it salicylaldehyde? Is it phenyl acetate? Or it is aspirin? Okay. So out of this four options, which one is? We have to find it out here. So when phenol reacts with NaOH, it will form phenoxide. Okay, it will form phenoxide. Here sodium phenoxide is being formed. When it is reacting with carbon dioxide at 140 degrees Celsius, the phenoxide will convert to sodium salt of phenol. Okay, sodium salt of phenol. Next, when the hydrogenation here it will take place in the presence of water, or hydrolysis will take place, then this salt will convert to 2-hydroxy 2-hydroxy ben, benzo carboxylic acid, benzene carboxylic acid. Okay. Further, when it will be reacted with acetic anhydride, it will undergo acylation and formation of aspirin. Okay, formation of aspirin takes place here. So hence the correct option will be option D, that is aspirin. Okay, it is one of the major reactions which is been taught in the alcohols and phenol chapter, because here a very important compound, that is aspirin, is been formed out here. So for today's class we have discussed about 10 questions here, and in the further class also I am going to discuss like this only the questions with you. So for today I am ending the class here only. In the next class we will meet with some new topics and some more questions. So thank you for today. We will meet up in the next class.